Okay, so now that we know all about gravimetric analysis, we're going to talk about how we can use gravimetric analysis as a tool to analyze water samples. So in this next portion of the lab, you get to design the procedure, and it's really important for you to think through a couple things in the procedure. So first of all, what are we going to do? Let me show you. We're going to meander on over to a sink here. And take a sample of some tap water. Now, everybody will get a sample of their own tap water, and we're going to analyze this sample of tap water for calcium. How much calcium is in this sample? That's the question that you're going to explore here. So you need to write a procedure that will help you investigate that and figure out how much calcium is actually in this tap water. As you design your procedure, I really want you to think through the details. So in the investigation paragraph here, it gives you a couple really important details, like your sample of tap water is going to be 20 milliliters. So you want to find out how much calcium is in a 20 milliliter sample of your tap water. Volume of sample, 20 milliliters. Okay, so at this point in time, I want you to think through your procedure like so. I want you to figure out what I want to do and then how you're going to do that. And you need to be very specific about this, like what is the volume you're going to add? What is the mass? How many moles? You need to specifically think through these kind of things. So go ahead and make yourself a procedure. Think through specifically how you're going to do all of these things. And then we'll come back together and talk through a couple more details. So pause the video and go. Okay, welcome back. So one of the important questions you should have thought about is how much sodium carbonate are you going to add to your water in order to get all of this calcium to precipitate out. So there's a couple different ways you can approach this. First of all, you could try a visual approach where you pour the two solutions together and see if much more precipitate forms. Now, that is a tricky way to do it because you're relying on your visual ability and you're forming a cloud at the same time. So it's probably not the most reliable approach. Another approach you could take is trying this experiment with a couple different trials. You could kind of do something similar to what we do when we're heating the water off of the filter paper. You could run a trial where you mix in a half a gram of sodium carbonate, and then you could run a second trial where you mix in a whole gram, and then you could run a third trial where you mix in 1.5 grams, and then a fourth trial where you mix in 2 grams. And you could just see if you get a difference in mass. And once your mass stops changing, once you seemingly hit your maximum amount of calcium that you can get to precipitate out, then you have added enough sodium carbonate. That's probably a pretty time-consuming effort. So a third way we could approach this is we can go do some research and try and figure out how much calcium is probably in our tap water. And I actually Googled that exact phrase, and I found this paper. It's listed on the NCBI website. in the National Library of Medicine and the National Institute of Health. It's a peer-reviewed paper, and it did some research for us as to how much calcium is in your drinking water. And luckily for us, they put their conclusions in their little abstract. Wait for it. Wait for it. Oh no, where did it go? Okay, here we go. So it shows here about how much water they or calcium they found in water. So for bottled water, the highest average calcium is 208.3 milligrams per liter. Notice that they're measuring calcium in density because it's convenient for them, whereas we are going to usually measure calcium in molarity because that's convenient from a chemical reaction standpoint. They also have here, they have some tap water measurements around the US and Canada. And the lowest is like 8.3 milligrams, and the highest is 131 milligrams. Phoenix, Arizona. Let's see if they have any other results. They have some results for filtration, like after they filter water, how much calcium is still present. Okay, so from these results, what I'm seeing is the lowest amount is somewhere around 8 milligrams per liter, and then the highest amount is somewhere around 208.3 milligrams per liter. So if we take the highest amount, we could even round that up to like 250 milligrams per liter. Our tap water is probably not going to be beyond that amount. And so we could start with that amount and convert to how much sodium carbonate we would have to add in order to precipitate all of that out. So why don't you go ahead and do that way, or you can do the trial way. You need one of those two methods in your procedure. So you either need a justification for how much sodium carbonate you're going to add based off of these levels. And again, the highest amount of calcium that this paper found in any tap water or bottled water or spring water was 208.3 milligrams per liter. So start with that. That's calcium, milligrams of calcium per liter. And you're going to want to use that and calculate out how much sodium carbonate you need to add in order to precipitate all of that. And then we're going to assume that our amount is less. Our amount of calcium in our water is less than that amount. Or you can do the 4 different trials and you can just do some guess and check and see when your results stop increasing. Either way, make sure you include it in your procedure. Also, you need a hazards and safety data table that compares calcium. Well, I guess the calcium's in tap water. So let's assume that's safe. So the only thing you need to look up is sodium carbonate. Okay, have fun.